lithium has 3 electrons. And so we know that those 3 electrons have to be placed into orbitals within a particular subshell. Now, if we kind of think back to the housing activity, we know that we had to start at the lowest floor, then fill up. And this is going to be the same principle that we're going to start in the lowest energy level, then fill up. So with lithium's 3 electrons, its first electron will go in the 1s orbital. And because the 1s orbital can hold 2 electrons, that's where we'll find its second electron as well. So here's lithium's first electron, here's its second electron. Now, its third electron, we've had to jump down to another energy level. But notice we're still talking about an s subshell. But in this case, we've only added 1 electron to that, so that will be 1. And if we'll notice, the numbers that we're putting here to denote how many electrons are within a given subshell, these should add up to the total number of electrons for the element. So for lithium, it has 3 electrons. 2 plus 1 is 3. Alright, so now let's keep going and let's do beryllium. So beryllium has 4 electrons. So again, we'll start by placing 1 within the 1s orbital, and since it can hold another one, then we'll place the maximum of 2 electrons within the 1s orbital. But now, we're going to move down to the 2s subshell. So within the 2s subshell, beryllium has 2 electrons. So that will be 1s2, 2s2. And again, if you'll note that when I add together these numbers of electrons, they equal the total number of electrons for the atom, which in this case for beryllium is 4. So again, we're just starting from the bottom and kind of filling electrons as we work our way down the periodic table. Or rather, we're going to work our way from left to right and then top to bottom on the periodic table. And the periodic table really here is serving for us as a guide to tell us what subshells the electrons are going to fill. So now let's keep going and look at boron. Now if you'll notice, beryllium was in the s block, but boron is going to be in the have an electron in the p block. So if we're to take boron and write its electron configuration, let's start at the top and work our way left to right and then top to bottom. So boron has a total of 5 electrons. So we'll start by placing its first 2 in the 1s subshell. Then we'll place its next 2 in the 2s subshell. So if you're kind of keeping up with our drawing we did earlier, so we placed 2 electrons in the 1s, 2 electrons in the 2s, and now we're moving to the p block. But in this case, boron only has 1 electron. It's the first spot in the p block, so that corresponds to 1 electron being placed in the p block. So therefore, we're still on the second energy level. It's the p block, but there's only 1 electron. And again, if we were to add these up, these would add up to 5, the total number of electrons for boron. Now let's do the next element, carbon. Again, we're going to start here on the periodic table and kind of follow the key to work our way down. So the first 2 electrons for carbon will be placed in the 1s orbital. So we'll have 2 there. Then the next electrons will be placed in the 2s orbital, which we also know can hold a maximum of 2 electrons. So then we're working our way again from left to right, and we arrive at the 2p subshell. But this time, instead of just 1 electron, carbon has 2 electrons within the p subshell because it's the second element within the p block. So this will be reflected as 2p2. Okay, kind of seeing a pattern start to arise here. How we keep adding on electrons and putting them in the proper subshells. Let's do one more within this p block. Let's do nitrogen. So again, we'll start at the top. 2 electrons in the 1s. 2 electrons in the 2s. Then we'll move over to our p block, and now we're 3 electrons in to the p block. So our electron configuration will be 1s2, 2s2, 2p. Again, we're 3 elements in, so our electron configuration will be 2p3. And so basically, you just keep following this pattern across the periodic table, working your way from left to right, and then top to bottom. And that should tell you the order that these subshells are filled. So now one thing that's important to note is that when you get down to the 4s subshell, then immediately after it, the D block begins. But if you'll notice, this isn't the 4th energy level for the D block. This is the 3rd. So the numbers kind of backtrack one once you get to the D block, 3, 4, 5, 6. And then this 4 kind of picks back up with the P block. All right, also for the F block, the numbering for their, quote, energy level starts at 4 and then 5. So let's do an element like vanadium. Okay. So, again, we're going to start from the top to find the order that we should fill these particular subshells. So, its first 2 electrons will go in the 1s orbital. So I'm going to denote that as the 1s with 2 electrons. Its next 2 electrons will go in the 2s subshell. So I'll denote that as 2s, again with 2 electrons. Now, again, we're moving left to right. So then we encounter the p block. So its next 6 electrons will all be placed within the 2p subshell. So I'll denote that as 2p6. So we've made it so far. So let's jump down another row. Then its next 2 electrons will go in the 3s subshell. I'll denote that as the 3s with 2 electrons. Then if we keep going from left to right, we encounter the 3p subshell, and again, we'll be able to place all 6 electrons there. So this will be denoted as 3p6. Okay, we're almost there. So now let's jump down to the 4th. So this is 4s. So its next 2 electrons will be placed within the 4s subshell. And then, if we keep moving along toward vanadium, we're going to run into the D block. And so this, since in the D block this is accounted for as the 3rd energy level, this will represent as oops, forgot those electrons, 3d. And now we just need to count how many elements in to the d block in order to determine how many electrons are within the 3d orbital. So let's count. We're looking at vanadium again. So 1, 2, 3. So this would become 3d3. Okay. So